Hi, this is Dr.T.Senthil Kumar from RVS College of Engineering Technology, Coimbatore, Department of Electrical Electronics Engineering. So in this video, we are going to see the topic called starters. And before going to starters, I want to give some introduction about three-phase induction motor. So three-phase induction motor, it's normally used 90% of industries using three-phase induction motor, and so here I'm clubbing induction start motors as well as starters for a starting purpose. So we are using a starter in order to run the induction motors, and before that the three-phase induction motor self-starting machines, and it works under the principle of electromagnetic induction principle with the RMF, rotating magnetic field. So we have two major parts in the induction motor, stator and rotor. So the induction motor works under the principle of electromagnetic induction principle. It's like as a transformer. So sometimes three-phase induction motor is also called rotating transformer because it's work under the principle of electromagnetic induction principle, which is same as that of a transformer principle. And here, so we have two types of rotor construction is there: squirrel cage induction motor and slip ring induction motor. And we have two types of parts: stator and rotor. So here, in order to rotate the induction motor, so we are using starters. So starters are not only for rotating the induction motor, it protects the induction motors. So starters is used to limit the starting current and to protect the induction motor. So this is the short introduction I want to give before entering the starter options. So here in starters, so we have five types of starters is used. The first one is stator resistance starters, auto transformer starters, star delta starters, rotor resistance starter, and last one is D-wheel starters. Yeah, first we are going to see stator resistance starter. This is the first method. So stator resistance starter is nothing but of you are adding a resistance in each phase of the three-phase induction motor stator side, right? So initially you are going to keep your resistance in maximum in order to reduce the voltage as well as reduce the starting current. So this is the main purpose of stator resistance starters, right? So here this is the schematic diagram of stator resistance starters. As I mentioned earlier, so we are giving an external resistance in the stator side of the induction motor. So it's here we have a squirrel cage rotor type. So the resistance kept in maximum during a starting point so that we reduce the applied voltage as well as the reduce the starting current. So if you decreasing the resistance to the resistance of the windings, so that the full voltage is applied to the stators, so the motor get started in good manner and attains the maximum speed, which means that the full voltage is applied to the stator winding of the induction motor. Here the advantage of stator resistance starter is it's a very simple and cheap, as well as there is some demerits of this method. It may be an the torque production of these type of is very good, very low, so that we have to overcome this method. So we have another type of starters called star delta starters. Next we are going to see the star delta starters. So next we are going to see star delta starters. So mostly 90% of induction motor, the windings are star delta. So for higher power ratings, they preferred star delta winding, so that we are going to use star delta starters, right? So here it's a very cheapest method, and as well as we have star delta starters, which is used for high power application. So obviously the power rating and voltage current ratings are very high, so that we are in order to limit the starting current, we are using star delta starters, right? So here in starting method, from this diagram, so we have a three-phase supply and we have a star delta conversion model, and we have a stator winding of induction motor and rotor squirrel cage rotors, right? So during starting purpose, the stator is connected in star format, and which attains some speed, it converts to the delta, right? During starting period, the starting current is limited. After the motor attains some speed, it changes to delta. This can be done by manually or automatically. And here for the delta conversions, the reduced voltage is overcome. The full voltage is applied to the stator winding. The motor attains the maximum speed with help of normal rated voltage. So here in this method, so we have to convert star to delta conversions. It is used for high power ratings. It's a simple, and construction is very simple, and cost wise is very cheap. Mostly 90% of the induction motor, they preferred star delta starters, provided the motor has star delta winding. Next, we are going to see auto transformer starters. So here, the auto transformer starter plays a major role for controlling the voltage. So auto transformer starter, the starter is, we can vary the voltage from 0 level to 440 level. If we consider it's a 3-phase supply, so we can vary the voltage from 0 volt to 440 volt. So here the 3-phase induction motor, again the auto transformer starter is used to control the voltage from 0 level to 440 volt level, right? So this is the schematic diagram, and so we have a 3-phase supply. So the 3-phase transformer, this is tapping is available in each phases, and we have a stator winding, and we have a squirrel cage type. So in this, the changeover switch is there. So this can be done by manual or automatic, right? So here, so the voltage is reduced by reducing the voltage, reducing input voltage that is fetched to the stator winding. Here, this can be controlled by tapping with the auto transformer, right? So here, if vary from 0 volt to 440 volt, so if we bring to 0 to 440 volt during starting period, the starting current is limited because of reduced voltage. The motor gets initially started and close to 50% of normal speed, or 70% of normal speed, or 80% of normal speed. Again, the changeover switch is changed with the help of manual operation or automatic operations. After 80% of normal speed, the full voltage is applied to the stator winding of induction motor. Your motor gets rotated with the maximum speed, and the full voltage is applied to the stator winding. So here the advantage of auto transformer is, it's again simple and cost very cheap. We can control the voltage very easily. Again, this comes under the stator voltage control method of induction motor. Right. Next, we are going to see the 4th type of starters, that is called rotor resistance starters. So as we discussed earlier, so we have 5 types. The first method is stator resistance starters, star delta starters, and auto transformer starters. So these 3 comes under stator voltage control method, and the model is, rotor model is squirrel cage rotor model. But we have in the next model, we have in different cases a starter called rotor resistance starter. So the here mentioned is rotor resistance starters, so that the machine type is, that is the rotor type is slip ring induction motor. Sir, as usual we know that, so induction motor have 2 types of rotors, squirrel cage rotors and slip ring induction motor. The squirrel cage rotors, the stator voltage control is applicable, and in rotor control method, slip ring induction motor is applicable. So here the rotor resistance starter, the name suggested that, so we are going to use slip ring induction motor. So it's a very important key point here. So from this diagram, so we have a stator winding as usual. Here in other side we have a rotor. In rotor slip ring induction motor, the rotor has a winding with a slip ring brush arrangement. We are going to connect the external resistance. The type is slip ring induction motor. We are going to vary the resistance of the rotor, so that we can vary the speed control of induction motor, or we can control the voltage of the induction motor. So this is the schematic diagram. So here the external resistance is inserted in each phase of the winding. I already mentioned that the rotor has a winding. In each phases the resistance is connected, or rheostat is connected. So we can vary the rheostat from maximum level to minimum level, so that we can obtain the speed control of induction motor, as well as we reduce the voltage or increase the voltage. So with the help of rotor resistance starters, we obtain the speed control method of induction motor. Next, we are going to see direct online starter. So in short form, it is DOL starters, and mostly in commercial, so they are using a DOL starters. Here the HP 1 HP to 5 HP, they are using mostly DOL starters. If you go for above 5 HP, so they are using starter maybe auto transformer starters. So the machine which having a low capacity, so DOL starters is preferred, right? So here mentioned that in case of a small capacity motor having rating less than 5 HP, so DOL starter is used. Again the starter which is used to limit the starting current of induction motor, and here so there is no need to reduce the applied voltage to control the starting current. It's a very simplest method because the machine have a low ratings, so there is no much causes for high starting current. So so that's why it's called direct online starters. The supply line is connected to the motor directly with the help of contactors or some arrangements of relay. So the starters is called DOL starters. Though it may be an reduce the apply voltage, again we have to protect the induction motor. So in normally, so we have four types of abnormal condition is there. The abnormal conditions are high current, low current, high voltage, low voltage. So in terms of current and voltage, I give four types of abnormal conditions. Again I mentioned here, in terms of voltage, high voltage is there, low voltage is there. In terms of current, high voltage, high current or low current. So we have to protect these abnormal conditions by using contactors arrangements or relay arrangements. So here in direct online starters, the supply is directly connected to the motor with the help of contactors and relays. So this is the circuit diagram of DOL starters, and we have a three-phase supply. So we have a fuse. The fuse is selected as per the nameplate of the induction motors. As usual, we have a general formula called for choosing the fuse rating 110% of a rated current of a particular motor, and we have a thermal overload relay, and so we have a contactors with an arrangements of thermal overload relay, and it's directly connected to the induction motor. So here we have a squirrel cage rotor because the machine, the induction motor has a squirrel cage type model. So here, so normally NO is there, so it's NO called normally open, NC is called normally closed. The normally open for starting purpose and normally closed, it's for stop purpose, right? So we have a magnetizing coil. It's a very important uh, parts in this DOL starters. So we are going to energized or de-energized with the help of NO and NC. So normally open is used for starting purpose and normally closed for start purpose, right? So if you on this DOL starters by using this NO, so automatically your NO get energized, your contact gets attracted, so that the three-phase supply is directly fed to the induction motor through the contactors and relays. If we have any problem, or if we go into switch off the induction motor, we can press this normally closed for stop purpose. If we open this contact, so the energy get de-energized, so that your contactor comes in original position or in off position, your supply is cut off from the three-phase supply, your motor gets in safe. So this is happened during only by our own requirements. If we want to stop the motor, I can press NC, or if we have a special arrangements in order to cut off the induction motor with the supply during any abnormal conditions. The abnormal conditions are high voltage, low voltage, high current, low current. So this can be automated with the help of microcontrollers. Nowadays the microcontrollers plays a major role. So lot of microcontroller production is there. So with the help of microcontroller, we can protect the induction motor with the 4 abnormal conditions. Next, we are going to see various types of starters comparisons. So as usual, so we mentioned that 5 types of starters is there. So the first one is stator resistance starters and auto transformer starters, star delta starters, rotor resistance starter, and fifth one is DOL starters. And we have a tabulations there. So here we have a stator resistance starters, auto transformer starters, star delta starters, rotor resistance starters, and direct online starters. And we have a 8 categories of comparison. The first one is voltage applied at start to the stator, and second is the cost of the starters, and third, so we have a comparisons of torque and current, and fourth one is ease of operations, the easiest way of operations and suitable for what type of rotors constructions, and sixth one is maintenance cost and the starting torque as well as the motor capacity. So these are the parameters we are going to compare with the starters. First we are going to see the voltage applied at start to the stator. So stator resistance can be controlled, and auto transformer model it can be again controlled. In starter starters 57.73% is controlled, and rotor resistance starter it can be controlled. In direct online starters 100% is controlled. The voltage is controlled. So actually this is the parameters we are discussed. In if we go for the cost wise, so stator resistance again it's a low cost, in auto transformer it becomes high, star delta starters it is lowest, rotor resistance again it is high because it's a slip ring induction motor, the external resistance is added, and direct online starter is low. The cost wise is low in stator resistance, high in auto transformer, lowest in star delta, high in rotor resistance, and low in direct online starters. And if we go for torque ratios and current propositions, so first we have to see the ratio of starting torque as well as full load. So if we compare with your current, so it is x of into square ISC divided by FL whole square into SF. So this is the current ratio between current, that is ISC current divided by full load current. So in these cases rotor resistance it's not mentioned here. So here the torque and full load starting torque and full load torque is mostly applicable in the squirrel cage rotor types. If we go for the operations or ease of operations, in rotor resistance it's a very easy, and auto transformer it's somewhat complicated. In star delta again it is easy, and rotor resistance it's again it's complicated because I mentioned here it's the type is slip ring induction motor, external resistance is added, so that they mention it is complicated, and direct online starters again it's ease of operations, and it's suitable for here SC and SR. So SC is nothing but of squirrel cage, and SR is nothing but of slip ring. So it can be both model can be used. Again both are in auto transformer SC and SR is used, star delta SC and SR is used, rotor resistance only SR, SR is nothing but of slip ring motor, and direct online both SC and SR is used. And if you go for maintenance, starting torque and motor capacity, so maintenance rotor resistance starter is low, starting torque is low, motor capacity is small. If you go for auto transformer, maintenance is high, starting torque is low, and motor capacity is medium and high. In case of star delta starters, the maintenance is low, starting torque is moderate, as well as motor capacity is medium. In case of rotor resistance, maintenance is high, starting torque is high, and motor capacity is medium or high. In case of last direct online starter, maintenance is low, starting torque is low, and motor capacity is small. So this is the comparisons of 5 starters with 8 parameters. So thank you so much for watching this video.